Okay, dear ladies and gentlemen, dear colleagues, my name is Novak NIKOLIĆ and I'm associate professor from the Faculty of Engineering, University of Kragujevac. On behalf of the authors, I will present the paper titled as Different Ventilation Methods and Their Impact on Energy Consumption for Heating a Kindergarten. Kindergartens are often neglected in terms of indoor air quality, especially in this geographical area, where the vast majority of them, including newly built ones, do not have mechanical ventilation systems. Only natural ventilation is performed by opening windows. So in such conditions, the quality of indoor air is often unacceptable. In the future, this type of buildings will have to meet the criteria of very low or net zero energy consumption, in addition to the criteria of the indoor environment quality. Importance of people occupancy and people behavior will only increase when moving towards net zero energy buildings or net zero energy kindergartens. In the building performance simulation softwares, people occupancy is often included through a fixed schedule. So to obtain more accurate energy demand simulations, realistic and detailed people occupancy schedules are needed. The objective of this study is to examine the influence of two ventilation methods, method 1 and method 3, according to the EN standard 16798, on the predicted heating consumption of a selected kindergarten in the city of Kragujevac. So this study for the first time includes the variable weekly occupancy schedules and the energy consumption, the predicted energy consumption of a building with ventilation system which operation is based on that people occupancy is compared with energy consumption related to the fixed occupancy schedules. As I said, two ventilation methods were considered, the method 1 and method 3. In the method 1, two ventilation requirements were selected, the C1 and C4 air quality category, which are characterized by the highest and lowest level of quality. And the simulations performed in the NG+ software are related for all of three levels of building pollutions, very low polluted, and no low polluted buildings. According to the method 1, the operation of the ventilation system is conditioned by people occupancy or presence of children in the kindergarten, while the method 3 or ventilation requirements for the method 3 do not depend on the people occupancy, which means that this value 0.5 HN per hour was adopted as the ventilation requirements. So three types of people occupancy were defined: real occupancy, which means it is variable weekly occupancy schedules, average yearly, and the maximum occupancy schedules, which are fixed schedules. So for that fixed schedule, it means that the airflow rate, fresh airflow rate, is constant during the heating period. The method 2 was not considered due to the impossibility of determining the emissions of critical or relevant pollutants for building and HVAC systems, and due to the fact that the limit value of CO2 concentration of 950 and 750 ppm correspond to the C1 and C4 air quality category of the method 1. So on this slide you can see the selected kindergarten. It is an existing kindergarten in our city. It consists of 3 levels. It has 39 heated rooms and also total heated floor area of 1270 square meters. It is surrounded by the buildings that affects its heating consumption. So this is the one residential building and this is the school building. The 3D model was made under the assumptions that the values of the overall heat transfer coefficients of all building elements, building constructions of these kindergartens fulfill our national requirements and criteria of our national rule book on energy efficiency of buildings. So I said before and earlier that we created three people occupancy schedules: real, average yearly, and maximum occupancy schedule. This is the picture with the real data regarding the people occupancy. So it is a real percentage children occupancy by educational groups in the selected kindergarten during 2016 and 17. This schedule was created from the educators or teachers' diaries. So it can be noticed that the people or children occupancy during this year is always below 100%. In one hand, the lowest people occupancy is recorded in December and January, as well as in autumn, in July and August, while the highest people occupancy was achieved in the spring and autumn months. The main reasons for this significant change in the people occupancy are annual vacations and the absence of children due to illness. Beside the variable weekly schedule, we defined 2 fixed schedules: average yearly and maximum people occupancy schedule. So the average yearly schedules are determined for on the basis of the real children occupancy of the corresponding in the educational group, but from 6 kindergartens in the same city for the period of 3 years, from 2015-16 to 2017-18. So in this table, you can see that it ranges from 44% for younger nursery group, or to approximately 57% to younger educational group. Maximum people occupancy schedule is based on the highest possible maximum people presence of children, which means that during the heating season, all time the people occupancy is 100%. Ventilation in this kindergarten, as well as in the other kindergartens, is performed naturally by opening the windows. Although there are no mechanical ventilation system, we assume that these systems, but without heat recovery for now, are installed in order to establish and maintain the proper quality of indoor environment. Only the rooms where children stay are ventilated. And in addition to affecting the operation of the ventilation system, the occupancy schedules also affects the heat gains. In order to bring the predicted consumption closer to the real one, we adopted the children heat gains from the literature. Okay, here are the results. You can see the predicted heating consumption of the kindergarten for the ventilation method 1, and air quality C1, very low polluted, no low polluted building, and the air quality C4. So blue bars represents the consumption for the real occupancy, red for average yearly, and green for the maximum occupancy. So the heating consumption increases with the increase, as it was expected, with the increase of the amount of fresh air from C4 to C1 NLP. For the C4, ventilation requirements amounts 4 liters per second person, while for the C1 category, the NLP, they amounts 14 liters per second person. On the other slide, you can see the predicted heating consumption, but for the method 3, for which ventilation requirements are 0.5 air change per hour. And when we have to when we looking at both of these methods, we have to firstly analyze the method 1. When we apply the maximum occupancy schedules, the heating consumption will be for all simulation cases be the highest, as it can be seen on this slide. So green lines, green bars. Why? Because the people occupancy is the highest. Also, you can see that the largest difference between occupancy schedules is in December and January, as you can see. Why? Because the children occupancy for these 2 months was the lowest in the heating period. Okay, with the method 3, we have the opposite effects, which means that the energy consumption, as you can see, decreases with the increase of the people occupancy. Why? Airflow rate is constant. It depends only on the volume of the ventilated rooms. When we have a higher occupancy, it means that we have higher heat gains, and in that way, lower heating consumption. More conclusions can be made if we compare heating consumption for real occupancy schedule with the heating consumption for the average and the maximum occupancy schedule. So this is the table in which we show seasonal percentage difference or deviations or error in the predicting of the heating consumption. So the results show that when we compare real and average yearly occupancy, the deviations amounts up to 3.9% for the method 1 and 2.4 for the method 3, which means that the error in predicting heating consumption is negligible. On the other side, if we compare a real consumption for the real occupancy schedule with consumption for the maximum occupancy schedule, the error is significant, up to 10.8 for the method 1 and 11.4 for the method 3. Okay, so what are the conclusions? Also, if we in building performance simulations if we use average yearly people occupancy schedules, the error in predicting consumption is around 3.9, around 4%, which on the first from the we can say that it can be neglected, but the question of the value of the error in predicted electricity consumption of the ventilation system, electricity consumption of the fans, as well as the energy consumption of the cooling system remains still open, especially bearing in mind that the children occupancy during most of the summer was extremely low, or the lowest. That will be the subject for future research. So in order to bring the predicted energy behavior of the building closer to its actual behavior, it is recommended to use the real occupancy schedule if it is possible to use. And on the other side, the maximum occupancy schedule in any case should be avoided. Thank you for your attention.
Thank you, colleague. Hvala kolega, da li ima nekih pitanja? Ako ne, ja imam jedan komentar, a pošto je moja oblast interesovanja slična vašoj, znači ovo je samo pokazalo da nama kao državi za bilo kakve analize su neophodni tipični rasporedi zauzetosti pojedinačnih prostorija, jer svaka analiza bi se svodila na case study, to je izuzetno skupo, ovako bi mogli da imamo tipičnu zauzetost jednog vrtića, male, srednje, velike veličine ili broja ljudi, isto važi za škole, bolnice i tako dalje, da ne dolazimo u situaciju da imamo ovaj najgori scenarij da sve te prostorije su stalno pune, a činjenica da nisu. Eto, toliko, hvala vam još jednom.
Da se pridružim komentarima, trenutno važeći evropski standard, a sad na srpskom ajde, trenutno važećem standardu, evropskom standardu koji se tiče prisustva dece u vrtićima ne može da se primeni u našem slučaju za naše vrtiće. Potpuno je drugi način korišćenja tih objekata u Evropi, nego u Evropskoj uniji, nego kod nas.
Zato je potrebno ono što imamo customize za nas, nismo mi mala zemlja, nema malog broja tih objekata, ovako bi se dobila kvalitetna rešenja.
Jasno.
Ok, hvala.
Hvala.